AQA Practice Paper, Set 1, Paper 3. Question 1. Simplify x to the 5 all raised to the power of 2. This is a power of power question. You can think of it as x to the 5 multiplied by x to the 5, which of course gives you x to the power of 10, as you have to add the indices together. Question 2. What is the sum of the exterior angles of a polygon? Circle your answer. The exterior angles of any polygon always add up to 360 degrees. Question 3. The bearing of B from A is 072 degrees. Circle the bearing of A from B. We are starting from B, so from the north line of B, which is a vertical line upwards. We go round in a clockwise direction until we hit the line joining us to A. So the bearing is this angle here. Now, angles on a straight line add up to 180 degrees, so this angle here is 108 degrees, which means that the bearing here is 360 subtract 108 degrees, which is 252 degrees. Question 4. Which of these points is not 5 units from the point 0, 0? If we draw a quick sketch, we can see instantly -5, 0 is 5 units away from the origin, as is 0, 5, which is up here. The point 3, 4 would be 3 units away and 4 units up like this, and if we use Pythagoras' theorem, this distance here, which is actually how far that point is from the origin, is 3 squared plus 4 squared all square rooted, which of course is root 25 or 5. Alternatively, we can see that this is a 3, 4, 5 right angle triangle. So this point is 5 units from the origin. This point is not 5 units from the origin. Question 5. Paul won a race with a time of 71.579 seconds. This time is to the nearest 1,000th of a second. Use inequalities to write down the error interval due to rounding. So if we call the time t, the lower bound is 71.5785 and the upper bound is 71.5795. Question 6. These two right-angle triangles are similar. Write down the value of tan x. Well, the tan of an angle is equal to the opposite side divided by the adjacent side, this side of course being the hypotenuse. So the tan of the angle is 9/12, or 3/4 to simplify. Notice you are not being asked to actually find the angle x using tan to the -1 or inverse tan. The question is asking what is the value of tan x. Question 6, part B, work out the value of y. There are a couple of different ways in which we can do this. Because the triangles are similar, their sides are in the same ratio. So if we look at matching pairs of sides, there's y and 12, and then there's 6 and 9. So these pairs must be in the same ratio, which means that y over 12, the ratio of y to 12, must equal 6/9. We then have to rearrange this equation to work out what y is. Y is equal to 12 multiplied by 6/9, which comes to a value of 8. The other method by which we can actually do this is knowing that tan of x is equal to 3/4. Well, we know that that's the value of the opposite divided by the adjacent, so we know that 6/y must be tan of x, which would then be equal to 3/4, and we would then have to solve this equation by rearranging. So 24 equals 3y, and y equals 8, multiplying by 4, multiplying by y, and then dividing by 3. Question 7. At a nursery, the mean age of 16 children is 31 months. Twins, each of age 26 months, join the nursery. So that's 2 children of age 26 months. And Katie also joins the nursery. The mean age of all 19 children is now 30 months. So we know that the mean average is equal to the total divided by the total number of children. So the total age divided by the total frequency, or the total number of children. Now, the mean of the 16 children is 31 months. So 31 must equal the total age of the 16 children divided by the total number of those children, which was 16. So the total age of the 16 must be 31 multiplied by 16. This comes to a value of 496. Now, twins, each of age 26 months, join the nursery, so to the 496 we need to add on 26 multiplied by 2, which gives us a value of 548. Now, when we take into account all of the children, the mean is now 30 months. So that means 30 must equal the new total of everybody in the nursery divided by 19. The new total age then equals 30 multiplied by 19, which comes to a value of 570. Now this 570 includes Katie as well, so to work out Katie's age we simply have to do 570 take away 548, which is the total age of the original 16 children plus the twins but not Katie. 570 take away 548 gives us 22 months, which is Katie's age. Question 8. John chooses a number at random from the digits 1 to 9. Matt also chooses a number at random from the digits 1 to 9. Work out the probability that the product of the two numbers chosen is a single-digit number. Product means we multiply, it does not mean we add. We're going to draw a quick sample space for each of the number choices. So John's numbers 1, 2, 3, 4, 5, 6, 7, 8, 9. And then Matt's number choices 1, 2, 3, 4, 5, 6, 7, 8 and 9. Now we're looking for all the single digit combinations that result from multiplying two of these numbers together. So we can see 1 times 1 would be 1, 1 times 2 is 2, and all of these would be accepted. 2 times 1 is 2, 2 times 2 is 4, 2 times 3 is 6, 2 times 4 is 8, but 2 times 5 is 10, so we cannot include any of these combinations after 2 multiplied by 5, which is 10. So we keep on going. 3 times 1 is 3, 3 times 2 is 6, 3 times 3 is 9, 3 times 4 is 12, so we rule out everything from here onwards. 4 times 1, 4 times 2, 4 times 3 is 12, not allowed, and so on and so forth. Now, if we look at all of the numbers that we have ticked, we need to count up how many of them there are. So 1, 2, 3, 4, 5, 6, 7, 8, 9. There are 23 products which are single digits. Now, there are 9 times 9 combinations overall, so that's 81 combinations, which means that the probability of choosing a single digit result is 23 over 81, which does not simplify. Question 9. The area of an ellipse, width A and height B, is given by this formula here. A rectangular photograph measures 15 centimetres by 10 centimetres. It is put into a frame as shown. The part of the photograph that can be seen is this ellipse here. Work out the percentage of the photograph that can be seen. So we're working out the percentage of the rectangle that is covered by the ellipse. So the area of the ellipse is equal to pi multiplied by 15 multiplied by 10 and then divided by, if we look at the formula again, divided by 4. This simplifies to a value of 75 pi over 2. The area of the rectangle is equal to 10 multiplied by 15, which is 150 centimetres squared. Now the percentage of the rectangle covered by the ellipse is the area of the ellipse, 75 pi over 2, divided by 150 multiplied by 100, which comes to a value of, so this comes to a value of 78.539 ... so an answer of 78.5% to 1 decimal place. Question 10. A flower shop sells 4 roses and 3 carnations for £6.10, 5 roses and 1 carnation for £5.70. Work out the cost of a rose and the cost of a carnation. We will call the cost of a rose X pounds and the cost of a carnation Y pounds. Now, taking each of these pieces of information in turn, 4 roses, so 4 multiplied by the cost of a rose, plus 3 multiplied by the cost of a carnation, equals £6.10. This is equation number 1. If we take the second piece of information, we can generate another equation, 5x plus y equals £5.70, equation 2. We have a pair of simultaneous equations. We're going to aim for the coefficients in front of the y terms to be the same, so we're going to start by multiplying equation 2 by 3. This gives us 15x plus 3y equals £17.10, or 17.1. Writing out equation 1 underneath that, we have 4x plus 3y equals 6.1, or £6.10. Now that we have both equations containing the terms plus 3y, we subtract. This gives us 11x equals 11, giving us x equals £1. We substitute this back into equation 2, which gives us 5 plus y equals £5.70, so y is equal to 70 pence, or £0.70. Question 11. A doctor claims that people who have poor sleep have twice the risk of having regular headaches than those who have good sleep. She collects data from 2,000 patients. We have a two-way table showing people who have good sleep and whether or not they have regular headaches or not regular headaches, and people who have poor sleep and whether or not they have headaches or not. Comment on the doctor's claim and show how you worked out your answer. So, this is a question that involves comparing data, and we're going to do this using percentages. So we're first of all going to look at the people who have good sleep from this column here. Now, if we look at the total number of people in that column, this comes to a value of 1,600. We want to know what percentage have regular headaches. Now, this is equal to the number who have regular headaches, 128, divided by 1,600, multiplied by 100. And this comes to a value of exactly 8%. We're now going to do the same for those who have poor sleep. So for the people who have poor sleep, the percentage with headaches, percentage of people who have regular headaches, is the total number of people who have regular headaches, which is 64, divided by the total number of people in this particular group, which, if we go back to those people who had poor sleep, there were 64 and 336, which comes to a total of 400. So to work out the percentage who have regular headaches, we take 64, the number who have regular headaches, divide by 400, the total number of people in that group, and multiply by 100. And this comes to an exact value of 16%. So we can see that the percentage of those who have poor sleep and headaches is double that of those who have good sleep and headaches, which would support the doctor's claim. What we need to do is make sure we write a sentence to finally answer this and to comment on the doctor's claim. So the doctor's claim can be supported Question 12. A teacher asks Amy and Jack to convert this number into standard form. Amy writes this. Criticise her answer. Her answer is incorrect because the first part of the number has to be between 1 and 10, not including 10. And this is our reason. We can write this in another way by saying if a times 10 to the x is a number in standard form, then a must be between 1 and 10, but not including 10. 12 part B. Jack writes this value here. Criticise Jack's answer. Well, Jack has used 10 to the minus 5 as the power of 10 in his answer, which would make the number a very, very small decimal. It should have been positive 5. So the power of 10 should have been positive 5, not negative 5. Question 13. At a concert, the ratio of men to women is 5 to 3, and the ratio of women to children is 7 to 4. Show that more than half of the people at the concert are men. So, if we think we have men, women and children attending this concert, the ratio of men to women is 5 to 3, and the ratio of women to children is 7 to 4. We want to try and give these ratios some commonality, so we look at these numbers here, 3 and 7, and we think that the lowest common multiple of 3 and 7 is 21. So in the first ratio for men to women, I'm going to multiply both parts of that ratio by 7, so we end up with a ratio of 35 to 21, which is equivalent to the ratio 5 to 3. For the ratio 7 to 4 of women to children, I'm going to multiply both parts of the ratio by 3, so the ratio becomes 21 to 12, which is equivalent to 7 to 4. This means that we now have the ratio of men to women to children as 35 to 21 to 12, so we can compare all three aspects of this. If we look at the proportion of men attending, this is equal to 35 over the total number of parts, 35 plus 21 plus 12, which is equal to 35 over 68, which is greater than a half. So more than half of the people at the concert are men. We could also say that half of 68 is 34, and 35 is clearly greater than this. Question 14. Use the quadratic formula to solve this quadratic equation. Give your solutions to two decimal places. So there's a clear hint here in the question. It's very obvious. We have to use the quadratic formula. We can't try and factorise this. There is no point. So we state our value of a, which is 5, our value of b, which is 11, our value of b squared, which is 121, and our value of c, which is -2. We have to memorise the quadratic formula. X equals minus b plus or minus the square root b squared minus 4ac, all divided by 2a. This gives us minus 11 plus or minus the square root of 121 minus 4 times 5 times -2, all divided by 10, which simplifies down to -11 plus or minus 161 divided by 10. We can then work out the two versions of the answers, the one involving -11 plus root 161 and the one involving -11 subtract the root of 161. The two answers come out to be 0.1688 ... and minus 2.3688 ... which if we round these to two decimal places we have answers of 0.17 and minus 2.37. Question 15. The universal set contains the whole numbers 1 to n. N is an even number greater than 100. O is the set of odd numbers, so 1, 3, 5, 7 onwards. P is the set of prime numbers, so 2, 3, 5, 7, 11 onwards. And S is the set of square numbers, so 1, 4, 9, 16, 25, so on. Explain why there are no numbers in P intersection S. So that is the set of numbers which belong in P and in S. So we're essentially saying that there are no numbers that are prime and square. Now, we can't just write that down, there are no numbers that are prime and square. We have to explain why. And we have to go back to the definition of a prime number. A prime number has exactly two factors, 1 and itself. A square number will have at least 3 factors. 1, itself, and its square root. The exception, of course, to this is 1, which is a square number and only has exactly one factor, but by definition 1 is not a prime number. Question 15, part B. How many numbers are there in O union P? That means the set of odd numbers or the set of prime numbers. Now, if there are n numbers overall, and n is an even number, then half of those numbers must be odd. So n over 2 odd numbers must be included in this set here. But we also have to account for the prime numbers too. Now, all of the prime numbers are odd apart from 2, which means that we have n over 2 odd numbers in this set, plus one even number, which is 2, which also happens to be prime. Question 16. A calculator gives a value of pi as 3.14159. An approximation for pi is this number here. Show that the value of the approximation is within 0.01% of the calculator value. So, Let's work out the approximation by working out what the root of 40 divided by 3 minus root 12 is. This is a value of 3.141533333871 ... Now the calculator value is 3.14159, which means that the calculator value is bigger, slightly bigger than the approximate value. So what we want to know is whether the approximate value is within 0.01% of the calculator value. There are a number of different ways of doing this. One way in which we can do this is to work out what 0.01% of the calculator value is. To do that, we can take 3.14159, the calculator value, divide it by 100 and multiply by 0.01. This gives us a value of 0.000314159. Now, we then need to subtract this from that calculator value. This gives us 3.141275841. Now this is smaller than the approximate value of 3.1415333 ... which means that this approximate value must be closer to the calculator value than this value here, which means it must be within 0.01% of the calculator value. So essentially what we've done is, if we have a sliding scale and this is our calculator value of 3.14159, what we've done is we've worked out that if we subtract 0.01%, we create a sort of 0.01% zone underneath it. The smallest number that can be in that zone is 3.141275. Now the approximate value was bigger than this. It was 3.14153 ... which means it's inside this 0.01% region. Question 17. The length of a plank of wood is 3 meters to the nearest centimetre. A piece of length 50 centimetres to the nearest millimetre is cut off. Work out the maximum possible length of wood remaining. Give your answer in millimetres. So, if we start off with the length of the plank of wood, which is 3 meters to the nearest centimetre, so 300 centimetres to the nearest centimetre, its lower bound is 299.5 centimetres and its upper bound is 300.5 centimetres. If we look at the piece that's of length 50 centimetres to the nearest millimetre, we'll call this length x. Its upper bound is 50.05 centimetres and its lower bound is 49.95 centimetres, as it's been given correct to the nearest millimetre, not to the nearest centimetre. Now, if we want the maximum possible length of wood to remain, that means if we want to use the minimum possible value that's being cut off. So our calculation is going to be 300.5, so we take the maximum length of the original plank of wood and we subtract from that the minimum possible length of wood that's being cut off, and this then gives us a value of 250.55. This, of course, is in centimetres, and to convert to millimetres, we have to multiply by 10, so this gives us 2,505.5 millimetres. Question 18. Y equals 5 root x over 2. Circle the expression in x for y squared. So y squared would equal 5 root x over 2 multiplied by 5 root x over 2, which gives us 25x over 4, this answer here. Question 19. The square of x is 7, so x squared equals 7. Circle the value of x cubed. Well, x will equal the root of 7, and x cubed will equal root 7 multiplied by root 7 multiplied by root 7. If we take the first pair and multiply them together, root 7 multiplied by root 7 is 7, so we then have 7 root 7, which can also be evaluated on a calculator. Question 20. W, x and y are 3 integers. W is 2 less than x, so w equals x subtract 2. Y is 2 more than x, so y equals x plus 2. Prove that wy plus 4 equals x squared. So wy is equal to x minus 2 multiplied by x plus 2, which if we expand the brackets is x squared plus 2x minus 2x minus 4, which simplifies to x squared minus 4. Then wy plus 4 is equal to x squared minus 4, which is the wy part, plus 4, which of course is x squared, which is what we were trying to achieve. Question 21. ACB is a straight line. A is the point 0, 8, and B is the point 4, 0. AC to CB is 1 to 3. So AC is 1/4 of the length from A to B, and CB is 3/4 of the length from A to B using this ratio here. Line DCE is perpendicular to line ACB. We have to work out the equation of line DCE. The first thing we're going to do is work out the gradient of line ACB, which of course is its change in y over its change in x, which of course is 8 over 4, but because the line is in this direction, it has a negative gradient. So the gradient of ACB is equal to -2. Now the gradient of DCE is equal to 1/2. It is the negative reciprocal of the gradient of ACB as they are perpendicular to each other. So we now have the gradient of DCE, which means that this line here must begin y equals 1/2 x, and then there's an extra component, which of course is its y-intercept, so we need to find out what this value here is, the y-intercept. To do this, we need a point on the line, and it's this point here, C, that we can find. Now, because the ratio of AC to CB is 1 to 3, the coordinates of C are going to be 1/4 of the way along the distance from O to B, which means that the x-coordinate of C is 1. Now, at this point here, there are a couple of different ways we can find the y-coordinate of C. We know that the equation of the original line is y equals -2x plus 8. We worked out its gradient over here, and it has a y-intercept of 8. So if x equals 1, which is what happens at C, then y would be equal to -2 plus 8, which would equal 6. So the coordinates of C are 1 and 6. Now, the equation of DCE is currently y equals a half x plus a constant. And we have to work out what this constant is. So we're going to substitute in this information here. 6 is equal to a half times 1 plus c. So c is equal to 5.5 or 11 over 2, which means that the equation of the line DCE is y equals a half x plus 5.5. There is another way of working out the y-coordinate of C using the ratio. Because this distance is 8, this portion here has to be 1/4 of the total distance, a bit like this portion here being 1/4 of the distance along here. The total distance from A to C is 8, 1/4 of that is 2, which means that this distance here has to be 2, which sets this value here as 6. 22. Kamal is working out the size of angle x in the triangle below. He assumes that angle ABC is a right angle. In fact, the size of angle ABC is 89 degrees. Explain the effect of Kamal's assumption on the accuracy of his calculation. You must show working to support your explanation. Now, let's assume that Kamal does the calculation with a right angle here. It's a right angle triangle. Let's label the sides, hypotenuse, opposite and adjacent. We can see that we are looking at using the opposite and the hypotenuse, so this is a question involving sine. Sine of x is equal to the opposite divided by the hypotenuse, so sine x is equal to 6 divided by 10, and x is equal to sine to the -1, inverse sine, of 6/10. And this would give us an answer of 36.8698, which is the inaccurate answer. Now, using the correct triangle, this isn't an accurate representation of the drawing, but this is our angle of x. That's 6, this side is 10, and this side is actually 89 degrees. And because this is no longer a right angle triangle, we can't use standard right angle triangle trigonometry. What we can do is use the sine rule because we have opposite pairs of sides and angles. So sine x over 6 will equal sine 89 over 10. Sine x would equal 6 multiplied by sine 89 over 10. And this is equal to a value of 0.5999 ... So x is equal to sine to the -1 of this number, which gives us a value of 36.8633 ... We then have to make a sensible comment on the answers, and we can say a number of different statements. They are the same to one decimal place. We could also comment that the inaccurate answer is slightly larger than the accurate answer. They are the same to the nearest degree. Or we could say that they are different to 2 decimal places. We do have to make a comment on this to collect the third of the 3 marks, but we need to make a sensible comparison. Question 23. AED is a straight line. This is a vectors question. AE is a plus 3b. AEB is negative a plus b. Read the information in the question and apply it to the diagram. 23 part A, work out the vector AB, this vector here. So we can see very, very clearly from the diagram that AB is AE plus EB. And we're going to write that out in full. So that is A plus 3B plus negative A plus B, and this comes to a total of 4B. 23b. Also, ED is a quarter of AD, and DC is negative a third of A. So DC over here is minus 1/3 A, and we know that ED, which is this vector here, is a quarter of this entire vector AD. Now this means that this vector over here, A plus 3B, is 3/4 of AD, with this part being a quarter. Now if this part is 3/4, then 1/4 is this divided by 3. So 3/4 of AD equals A plus 3B. So 1/4 of AD must be 3 times as small, which is a third A plus B if you divide each of these parts by 3. So the vector ED must be 1/3 of A plus B. So this vector here, this is ED. We have to prove that EC is parallel to AB. Now the vector EC, as you can see from the diagram here, is ED plus DC. So EC equals ED plus DC, which is 1/3 of A plus B plus negative a third of A. This simplifies to B. The vector AB is equal to 4B, which is 4 multiplied by EC. And we can see that as the vectors are multiples of each other, the lines are parallel. So AB equals 4EC, i.e. AB and EC are parallel. Question 24. The time of each swing of a pendulum, length L centimetres, is t seconds. T is directly proportional to the square root of L. Write that like this. Alternatively, T equals K root L. It does have a lowercase l in the question. I'm writing a capital L here just to make the question a little bit clearer and to avoid any ambiguity. When L equals 90.25, T equals 1.9. So 1.9 equals K root 90.25. So K is equal to 1.9 divided by the root of 90.25, giving us K equals 0.2. So we have the relationship T equals 0.2 root L. Work out the value of T when L is 132.25. So T equals 0.2 multiplied by the root of 132.25, which is a value of 2.3 seconds. And we can fill that in over here. Question 25. The graph with equation y equals x squared is translated by the vector to 0. So, if we sketch a diagram of this, this is the graph y equals x squared. This translation over here is a translation of 2 units in the positive x direction. So this is what the graph will look like after the translation. So we can see it is very clearly the graph of y equals x minus 2 all squared. Question 26. Here is a sketch of a speed-time graph for part of a journey. The average speed from 0 to t seconds, i.e. the whole of the journey, was 3.6 meters per second. Work out the value of t. Now, we know that average speed is equal to total distance divided by total time. We don't know either of these values, and we're actually trying to find the total time. So, we have to work out the distance travelled. The area under the graph in each section represents the distance travelled. Area A is a triangle. Its area is a half multiplied by its base of 8 multiplied by its height of 4.5. This comes to a value of 18. Area B is a rectangle which has a base of 6 and a height of 4.5. This gives B a total area of 27. Now C is a trapezium, and the area of C is a half the sum of the parallel sides 4.5 and 3.5 multiplied by the distance between them, which is t take away 14. So this distance here is the difference between t and 14. Now, if we add those three values together, the total distance travelled is 18 plus 27 plus a half times, and 4.5 plus 3.5 is 8, times t take away 14. This simplifies to 45 plus 4t minus 14. Now we know that the average speed, 3.6, is equal to the total distance, 45 plus 4t subtract 14, divided by the total time of t. And we now have an equation, a simple equation to solve. Multiply both sides by t, and we have 3.6t equals 45 plus, and we're going to expand these brackets in the numerator, 4t take away 56. Simplifying a little further, 3.6t is equal to 4t take away 11. So adding 11 to both sides and subtracting 3.6t will give us 11 equals 0.4t. So t equals 11 divided by 0.4, which is equal to 27.5 seconds. Question 27. For all values of x, f of x is 4x take away 3 over 5. Work out the inverse function f minus 1 of x. So let's think about what happens to x. It is multiplied by 4, we then subtract 3, we then divide by 5, which gives us our final answer. We have to reverse all these steps, multiply by 5 first, add 3, divide by 4, and that takes us backwards. So the inverse function, f minus 1 of x, is 5x plus 3 divided by 4. And of course, it's important to make sure we write this in the answer space. Question 28. The region R satisfies the three inequalities. Show the region R in the grid. So firstly, x is greater than minus 3. It's greater than, so this will be a broken line at minus 3, which we're going to draw on here. So So you can see here's the line x equals -3 drawn as a broken dotted line. The next inequality is x plus y is less than or equal to 2. So we're going to start off by plotting some coordinates which would satisfy the equation x plus y equals 2. This will be a solid line as the inequality is less than or equal to. So points that would satisfy this: 0, 2, 1, 1, 2, 0, -1, 3, -2, 4. And at this point we have enough points in which to confidently draw a line. Please use a ruler to draw this line. It's difficult to do so on the iPad app. So this is the line x plus y equals 2. Now, we're going to start shading the regions that we are not interested in. So if we look at the first inequality, x is greater than -3, which means we do not want the region to the left of this line. So I'm shading the unwanted region. We also want x plus y to be less than or equal to 2. Now, if we check the point 0, 0 plus 0 is less than 2, which means we want that point, which means we don't want any of the points above the line. The last inequality, y is greater than or equal to x over 2 minus 1. We're going to set up a mini coordinate table, x and y, and because x is being divided by 2, we're going to use even values of x as coordinates to make the calculation simpler. If x is 0, y is -1. If x is 2, y is 0. If x is 4, y is 1. And if x is 6, y is 2. We're going to plot those points: 0, -1, 2, 0. We can't actually plot 4 and 6 as they are not on the axes, so we will do one further calculation, -2, which would give us a y coordinate of -2. And we can plot this point as well. We'll join these up with a straight line. And again, please be careful and use a ruler when drawing your straight line. It's a solid line again because this is a greater than or equal to inequality. Now, checking the points again, if we use 0, 0. Now the rule is we want y, for this third inequality, y has got to be greater than or equal to x over 2 minus 1. So if we pick x equals 0, 0 divided by 2 is 0, take away 1 is -1, and the y coordinate of 0 is greater than or equal to this calculation, which gives us -1, which means that this point would be included, which means we want to reject everything outside or underneath this red line. So the region R that's required is this triangular region here. Work out the maximum value of 2x plus y in region R. Well, if we pick this point over here, where x equals 2 and y equals 0, then 2 times 2 plus 0 equals 4, and that is the maximum value of 2x plus y.